Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi. Now it is analog circuit part 2, IISC Bangalore previous year question series, and we are dealing with 2002, 2008 and 2016 question paper that was conducted by IISC Bangalore. Okay, and because this year again the paper will be organized by what? IISC Bangalore. Okay. So in part 1 already I have solved number of questions. Now I am going to solve remaining questions. Okay, and I think you have got the PDF of previous session, that is the part 1 and EDC, on my Telegram channel. So are you ready to solve some important questions? Right. Now in this session we will deal with very important questions from all the topics, especially from operational amplifier, and then from BJT, and then from what? MOSFET. And we will deal with questions from electrical branch as well as from electronics branch. Okay. Now, first of all, this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience and I have trained more than 1 lakh students for these competitive exams. And I have qualified and selected for engineering services exam that is conducted by UPSC. These are my ranks, guys. Okay. And UPSC interview is going on. So if you want mock interview, then share your result with us. Okay, guys. Now, this is my Telegram channel. Here I will upload the PDF of this session. If you want to improve your concepts, then again you can join. And if you want to get the notification about my classes, then you can join my Telegram channel, that is Electronics by Sanjay Rathi. And that is the UPSC Engineering Services 2023 mains results out. You can share your result and get free mock interview with our expert panel. Right? याद रखिएगा, इंटरव्यू में ना मार्क्स वेरी करते हैं फ्रॉम 60 टू व्हाट 160. अगर आपने 2-3 मॉक इंटरव्यू दिया तो आपके नंबर इंक्रीज कर जाएंगे अप टू व्हाट 160 और आपका सिलेक्शन श्योर हो जाएगा, आपकी रैंक इंप्रूव कर जाएगी. तो इसे कैजुअल मत लेना और इंटरव्यू की अच्छे से तैयारी कीजिए. ओके, अब आते हैं जरा, ये है पहला क्वेश्चन. आई हैव गिवन दिस क्वेश्चन एज अ होमवर्क. तो टेल मी व्हाट इज द आंसर फॉर दिस वन. yesterday I have given this question as homework. That is the question in 2008 electronics branch, 2 marks from 555 timer. Then quickly we will solve this. Then this is a 9 volt battery. What is asked in the question? An unstable multivibrator circuit. This is a unstable multivibrator or square wave generator. Remember, 555 timer is an 8-pin IC. Here 4 is called reset, 8 is called supply, 1 is called ground, that is connected to ground. This is pin number 1. 2 is called trigger, 6 is called threshold, 7 is called discharge pin, and here we are taking the output from the pin number 3. This 3 kilo ohm is connected here, 10 kilo ohm is connected here, 12 kilo ohm resistor, it is connected to pin number 7, and the capacitor will discharge through this path. And this is the VCC. This is the VCC, and that VCC is given as 9 volt. VCC is given as 9 volt. What is asked here? An unstable multivibrator circuit using 555 timer is shown below. Assume that the circuit is oscillating steadily. The voltage VC across the capacitor varies between, what is the voltage across the capacitor? Okay. Now in a 555 timer, if this pin voltage across the VC is connected to pin number 2 and pin number 6, then the range is what? VCC by 3 to 2 VCC by 3. VCC by 3 to what? 2 VCC by 3. But in this question, what is the difference here? It is not connected. Watch this carefully. Watch this carefully, this diagram. When we are watching this diagram, the voltage across the capacitor is connected to pin number 2, that is the trigger, pin number 6, that is the threshold. In that case, the voltage across the capacitor will vary between VCC by 3 and 2 VCC by 3. That is the range under standard condition. Like this. And capacitor will charge, discharge continuously, but it will remain between VCC by 3 and 2 VCC by 3. What is the VCC? For example, 9. It will become 9 by 3. means 3. it will become 2 by 3, 9, that is what, 6. It will vary between 3 and 6 if it is connected to 2 and 6, right? Means what is the role of the threshold voltage? When the voltage increases, because of this pin, the maximum voltage of that point will be fixed at what? 2 VCC by 3. Means maximum voltage at this point during charging is 2 VCC by 3, it is fixed. This is the internal working of the 555 timer. And when the capacitor will discharge, because of the pin number 2, it will discharge up to only VCC by 3, and it is the lowest value, right? It is the highest value and it is the lowest value of this point, which point is connected to threshold pin. So this capacitor voltage is connected, but in the given diagram, watch it carefully. Watch this. This pin number 2 means this pin. This is nothing but voltage across the capacitor. Is connected to pin number 2, and therefore the lowest value of VCC is VCC by 3. VCC by 3, that is nothing but 3 volt because it is 9 volt VCC. Okay. But what is the highest value of VC? Then it is not connected to 6. This point is connected to 6. So what is the highest value of the Vx? The highest value of the Vx is 2 VCC by 3. Why 2 VCC by 3? Because it is connected to pin number 6. So 2 into 9 divided by 3, that is the 6 volt. But this is not VC, this is what? Vx. When this is 6 volt, what is the voltage at this point? Then watch this. This is the value and this is the capacitor. This is 30 kilo ohm, this is 9 volt, this is 10 kilo ohm, and the voltage at this point, maximum voltage at this point is 6 volt. At that time, what is this? At the same instant, what is the voltage at this point? 9 minus 6 upon 30. So what will be the current here? 3 by 30. 9 minus 6, 3 by 30 means 1 by 10. 1 by 10 milliampere current. Same current will flow because current enter into the 555 timer is 0. What will be the drop here? 1 by 10 into 10. That is 1 volt. The drop across this resistor is 1 volt. If it is 6 volt, 6 minus 1 volt, what is the voltage at this point? 5 volt. The maximum voltage across the VC is what? 5 volt. 5 volt. So answer for this question is 3 to 5 volt. A, not 3 to 6 volt. The number of students will give this answer, but that is wrong. Now guys, if you want to get the more detail about 555 timer, I can arrange one complete 1 hour session for 555 timer. Write comments on comments box as well as on my Telegram channel, so that we will arrange one session, and within 1 hour you will get the complete command over what? A stable multi-vibrator by 555 timer with internal diagram. What is the pin number 6? Why to restrict the value up to what? VCC by 3. Why the pin number 6 will restrict the highest value up to what? 2 VCC by 3, guys. So that is the answer. Now 3 to 5 volt. This is the answer for question. This is in 2008 EC 2 marks. Then if the very simple question that is asked in what EC, this is of 1 marks in same year 2016, that is in 2008 then 2016. But this is a standard or stable multi-vibrator. It is written, means square wave generator. Here we are getting the output. RA, RB, C. In this case, you can directly use the formula from the frequency 1 by T. Initially, I have given the answer 1 upon 0.69 RA plus 2 RB into C. This is the standard answer for this question. This is RA, this is RB, and that is C. So this is important diagram. On this diagram, there will be one more question, that is on duty cycle, right? And how we can adjust the duty cycle. This is another important question based on this diagram. Duty cycle is another important parameter. D. Okay. Now, next question, because only the frequency is asked, so that is to find the frequency, you can use this formula. 0.69, RA is given, RB is given, C is given. You can use this and you can get the frequency of this signal. Then this is about the 555 timer. Okay, next question is, consider the circuit shown in the figure. Now everyone try to solve this question. Consider the circuit shown in the figure assuming VB1 and VEB2. What is written here? VEB means that is for PNP transistor. So watch the diagram carefully. Which one is the NPN and which one is the PNP? This is NPN. This is PNP. Right, this is the 0.7 drop. In PNP we are calculating VEB. This is the E and this is the B. So VEB, it is what? 0.7. This is 2.5 volt and this is shorted. This is shorted, guys. When this is shorted means base is shorted with the collector. What is the VBC? VCB will become 0. The voltage from this point to this point, it is 0. Then what is asked here? The value of the DC voltage VC2. Value of the DC voltage DC2. 2-mark question in 2016. Now watch this diagram carefully. Then here, if you want to find the VC2, you have to find the current here. That current is nothing but IC2 because it is a transistor Q2. This is the transistor Q1. Beta 2 is given as 15. You have to find the IC2. Now, to find the IC2, you have to find what? IB2. IB, and remember in NPN transistor, what is the IC2? This is IE2. IC2 outside, right? IB2 is also outside. This is the direction of IB2 in case of PNP transistor. IE2 inside, IB2 outside, IC2 outside. For NPN transistor, IC2 inside, IC1 inside, IB1 inside, and then IE1 outside. That is the proper direction. Now, this is 0.7 volt. This is also, what is the voltage from this point to this point? This voltage is called VCE1. Since collector and base are shorted, so anyone can ask, sir, it is a 2.5 volt. No, 2.5 volt, base is 2.5 volt, collector is 2.5 volt. So what is the voltage between base and collector? 0. Means it is short circuit. So both the points are connected to same battery, and that's why I am saying that it is short circuited. So VCB is 0. So what is the value of VCE and VBE? So VCE, you can write VC minus VE, and you can write it like that. VCB minus VEB with respect to base, this is 0, and you can change the sign of this. Both are equal. So VB, this is VCE is 0.7. 0.7 volt. The voltage at this point is 0.7 volt. Now you can write the KVL from this point. This is 2.5, this is 0.7, this is 0.7 because this drop is VEB 0.7 volt. So from this point, you can write a KVL and then you can find the value of IB. What is the value of the IB here? This is 2.5 volt is equal to VCE1. What is the VCE1? 0.7 volt plus VEB, this is the 0.7 for PNP transistor, this 0.7, this 0.7 plus IB2 into 10 10 times of IB2 plus 1 volt is equal to 2.5. It will become 1.5 minus 1.4, 2.5 minus, this is the 0.7, 1.4 plus 1, 2.4 divided by 10. It is nothing but 0.1 divided by 10 milliampere. Now, what is the I beta for this? IB2 50. So, what is the IC2? You can find the IC2. 1 minute. IC2. Beta 2 times of IB2. Then it will become 50 into 0.1 divided by 10. That is 0.5 milliampere. This is IC2. When 0.5 milliampere is multiplied with the 1 kilo ohm, then what is the VC2? VC2 is equal to 1 into IC2. Kilo multiplied with the milliampere cancel out, and answer is what? 0.5 volt. Answer is 0.5 volt. So guys, give me the comments that everything is fine now. Okay. Is it audible? Then this is the 0.5 volt is the answer for this question. So here this is the answer. Then next question is, next one. This is on CMOS, guys. This is on CMOS. Now, this is in 2002 EC 2 marks question. Consider the following statement in connection with the CMOS, that is complementary metal oxide semiconductor field effect transistor inverter in the figure, where both the MOSFETs are of enhancement type and both have a threshold voltage of 2 volt. Both have the threshold voltage of 2 volt. Statement 1. What is the statement 1? T1 conducts when Vi is greater than 2 volt. T1 conducts when Vi is greater than 2 volt. T1 is always in saturation when V0 is equal to 0 volt. This is a CMOS transistor. CMOS means, watch this diagram. According to symbol, this is the enhancement type MOSFET. Right? Initially we are using this type of symbol. Now, but these days we are not giving the discontinuous channel. That is the language of what standard textbook. That is what we are using this type of symbol in Milvan Halkias. So when this is a discontinuous channel like this, so this is called E-type MOSFET. Or if suppose we are having the continuous channel, this is called D-type MOSFET. D-type. Right? Now, whether it is a NMOS or PMOS, it is decided by arrow. If the from body terminal, if arrow is inside, means body is P-type, channel is N channel. So this is the NMOS and that is the PMOS, and this is overall CMOS. Okay, normally this body is sorted to source. So body is sorted to source, body is sorted to source. When we are giving the voltage Vi greater than 2 volt, definitely we are getting the VGSN. VGSN means gate to source voltage across NMOS greater than 2. And what is the threshold voltage? 2 volt. If the Vi is greater than 2 volt, VGSN is greater than 2 volt, and that's why this diode will conduct. So T1 will conduct when we are giving the Vi greater than 2 volt. So that is the correct one. That is the correct one. T1 conducts when Vi is greater than 2 volt. T1 is always in saturation when V0 is 0 volt. We can't say. If suppose we are giving it 0 volt, VDS will become 0. Guys, if the VDS is 0, what is the condition for the saturation? VDS should be greater than or equal to VGS minus VT. That condition is not possible. VDS greater than or equal to 0, that is VDS minus VT. If suppose we are taking the ideal condition and this path will act as short circuit, then V0 will become 0. But in that case, this condition will not satisfy. VDS greater than or equal to VGS minus VT. That is required for saturation. Means that second statement completely wrong. Second statement is wrong. No. The answer is only statement 1 is true. Then next one, if you are attending the session, everyone try to give the answer for this question. Next one. Guys, you can download our BYJU'S exam prep app from Google Play Store, and if you are giving the mock test, PYQs, you are solving, then you will get this results like this. That is called leaderboard. Participants 60 students. What is your rank? First rank, second rank, third rank, fourth rank, and so on, right? And what is your score? Everything will be given here. Okay, तो आप अपने रिजल्ट्स की एनालिसिस कर सकते हो और आपको आइडिया लगेगा कि आप कितने पार्टिसिपेंट्स यहाँ पार्टिसिपेट कर रहे हैं और आपकी पोजीशन क्या है. And you can also give the mock test here. So first of all, you have to install the Google Play Stores, and there are number of previous year question papers and mock tests you can attempt there. Okay. Then in the circuit shown in the figure, the transistor M1 is in saturation. Where is the M1? This is the M1 in saturation. 50 picofarad, 1 kilo ohm, 5 kilo ohm resistor, and has a transconductance GM 0.01 Siemens. Ignoring the internal parasitic capacitance and assuming the channel length modulation lambda to be 0. The small signal input pole frequency is lambda 0, means we have to neglect the early effect. And what is asked? Small signal input pole frequency. This type of questions normally asked in what? Electronics. Normally this type of question not for electrical branch. But how we can find the frequency? I am just using the word normally. It is in syllabus, but this type of questions for electronics student. Then here we have to apply the Miller's theorem. What is the Miller's theorem? First of all, draw the small signal model for that. What is the small signal model for this? This is the gate. Gate is open, source is shorted to the ground. This is GM-VGS. If the early effect is negligible, then R0 will, RD will infinite, so you can remove the RD. Then this is the case. Here gate terminal V in is connected with respect to ground and 5 kilo ohm resistor is connected to the gate terminal. You can connect here. And V in is connected here. This is the model, and this gate to source will act as open circuit because up to this point the input resistance is infinite. But now one capacitor is connected between drain and what? Gate. And from drain, when we are doing the small signal analysis, VDD will act as 0. From drain to ground 1 kilo ohm is connected. In model we are having the RD here, and then from drain to ground, this is small RD and that is the capital RD, means it is 1 kilo ohm. It is connected here. And here we are taking the output. And RD, what is the RD? 10 kilo ohm. RD. And what is this small RD? Infinite. Why? Because early effect is negligible. So this is the early, because of the early effect, lambda is 0. So what is the RD? 1 by lambda ID. So lambda is 0, that's why it is infinite. Now, here we are having one capacitor connected between these two. This is the 50 picofarad capacitor. Okay, that is the model, right? Now, how we can solve this and how we can find the pole frequency? You have to apply the Miller's theorem. What is this? What is the voltage from this point to this point? This is called VGS from this point. And what is the voltage at this point? V0. If you have the relation between V0 and VGS, that is called AV. V0 by VGS. Then you can apply the Miller's theorem. So after Miller's theorem, what this diagram, you can break this capacitor. One capacitor at the input side and another capacitor at the output side. This capacitor is given by CGS. This is called gate and drain, CGD. 1 minus AV. And one capacitor will be here, because a small RD is infinite, you can open it. Now this is required, CGD into 1 minus AV. Remember, the value of this capacitor is very, very high. That's why it will almost act as what, as compared to what, 10 kilo ohm resistor. So when it is 10 kilo ohm resistor, it is very high. You can ignore it, right? Because it is in what, picofarad, right? What is the value he is given? Picofarad. And that's why when we are giving the value, actually it is C2 is equal to this is the formula, 50 farad, this is CGD between gate and drain. Then AV is very large, AV cancel, it is nearly equal to what, CGD. Since AV is very large, so CGD. C2 is CGD and CDG in picofarad. Because of this, impedance is very large. This is very, very large as compared to RL or RD, 10 kilo. You can ignore it. What is the output voltage? Then you can write the output voltage as minus of GM VGS RD. What is the small RD? Infinite. So what is the V0 by VGS? That is nothing but AV minus GM into RD. What is the value of the RD given in the question? GM 0.01, and what is the RD? 1 kilo ohm. So what is the GM RD? (0.01) into what? 1. That is given here, 1. This will become 0.1. This is the value of GMRD, 0.1. It is in Siemens, it is in kilo ohm. Remember, if it is in Siemens, if it is in kilo ohm, you have to use the 1000 here. You have to use the 1000 here. It should be in ohm. Then it will become 10. Then it will become 10. So remember, when we are reading the 0.1, the gain is very low, but for MOSFET the gain is very, very high. That's why again you can check your calculation. Now you have got the VGS AV minus GMRD. This is equal to minus of 10. This is the GMRD minus 10. Now to CGD 1 minus AV, so minus of minus plus, it will become 11. 11 times of CGD. Because it is 10, 11 times of CGD. And what is the CGD? 50. So what is the CGD into 1 minus AV? Now finally, what is the cutoff frequency? Lower cutoff frequency from the input side or one pole because of the input side. Now you can find final answer. Simply focus on the input side. One pole, 1 by 2 pi. This is R. What is the R? 5 kilo ohm. That is the general formula. Directly you can use this formula. And now put these values. One upon 2 pi into 5 kilo ohm, 5 into 10 raised to power 3 into 11 times, because already I have proved this is the 10 minus 10, 11 into CGD, 50 picofarad. 50 into 10 raised to power minus 12. And then please solve it and you will get the cutoff frequency, right? Then guys, you will get this answer, 57.87 kilohertz. 57.87 kilohertz from this. So if no need to derive it, it is a standard answer in exam. Directly we have to break this by using the Miller's theorem. Then what is the value? CGD 1 minus AV. And what is the AV? AV is equal to minus GMRD. Right, and then find the value. Finally, directly use this formula and you will get the answer. Okay. Now, next question again from the MOSFET. We are getting the question, continuously we are getting this question, gain of the system. What is the gain of the system? So, Mansavi, what about the paper HAL? Everyone? Okay, today that was the paper for HAL. No? Okay. Now, in the circuit shown in the figure, the channel length modulation of all transistor is non-zero. Where is the channel length modulation? Yes, lambda, non-zero. In previous question it was 0. Now it is non-zero. Non-zero means we have what? R0. If we have the R0, also all the transistors operate in the saturation and have negligible body effect. Negligible body effect. The AC small signal voltage gain V0 by V in of the circuit is. What is the V0 by V in? How we can find the V0 by V in? That is the in a trans conductance or in terms of output resistance that is given. You have to find the answer. Then you can use the small signal model here. You have to give the small signal model here. Watch this. This is the PMOS. First of all, remember this is the source, this is the drain, and that is the source to drain voltage. Source to gate voltage VSG. Okay. This is for AC analysis, make it 0. Here we are giving the V0, here we are getting the V in, and source to gate terminal is 0. That's why the VSG will become 0. And then there is a M2. Then you can use the model here. What is the model here? Watch this. For this diagram, because it is a DC voltage, you have to make it what? 0. For a small signal analysis, all the DC signals should be 0. That's why the VSG3, this is for 3, it will become 0. It will become 0. Now watch this. This is 0. What is the VSG, VGS? This is S, this is NMOS, VGS2. 0 minus V0, that is the minus V0. Minus V0. And this is the VGS1. VGS1 is nothing but V in. VGS1 is nothing but V in, and that is the V0. It will become minus V0. Since it is 0, but no need to find a VDG, right? It is the, we have find the VGS2 is equal to V0. Now anyone can be replaced by what? Small signal model. Then what is the model here? GM3 sorry, into VGS3. Here we are using R03 because early fact present, lambda is not 0, R03. Then you can draw like this, or you can change the orientation because the source is above. Then you can towards source. Source is connected to ground. Okay. Then what about the gate? Gate is also connected to ground. So what is the VGS? Already I have given 0. 0. And that's why this portion will act as open circuit. Now this is the drain terminal. Drain terminal, this is the drain of this. Third. This is connected to what? V0. This is the drain D3. Now, draw the model for this. GMVGS1. R01. This is Vin. This is gate 1 and that is the source. So what is the voltage from this point to this point? Already we have given Vin. This is the minus. So that will become GM1 Vin. This is the R01 and then we are taking the output from this point. This is the output from this point. Okay. Then again watch this. If you are watching this, then this is also, this is the arrow, sorry. This is the diagram then, this one. Now, this is the model. This is the M2, this is the M1. We are taking the output from this. This D3 is connected here. And finally, for model for this. And what is the VGS2 minus V0? Already I have given VGS2 is minus V0 and that is R02. This point is connected to ground and this point is again connected to what? V0. So that is the model. Now simply you have to apply what? KCL at this point and you can find the gain. What is the KCL here? If you are going, first of all remember this is the GM1 Vin and that will become what? Minus GM2 V0 and this is 0 because it will act as open circuit because this is 0. Now when I am writing the KCL, this will become, what is the outgoing current? GM1 Vin plus what is the outgoing current? V0 upon R01 plus V0 minus 0 upon R02 plus V0 minus 0 upon R03 plus what is this? Incoming current. This is minus. So what is the outgoing current? GM2V2. GM2 V0 positive because the incoming current is minus, the outgoing current will become plus GM2 V0, right? And that is all over. This is the first, second, third, fourth, fifth. First, second, third, fourth, right? And then okay, I think everything is over now. 1 2 3 4 5. Yes, is equal to 0. From this you can find the V0 by Vin, that will be the negative, and these all are 1 by R01, 1 by R02, 1 by R03 and GM2. It is nothing but resistors. This and this is connected in what? Parallel actually. So you can write the V0 by Vin, that is nothing but minus of GM1 and 1 by R01 parallel with R01, sorry, not because these resistors are connected in parallel. R01 parallel with R02 parallel with R03 parallel with GM2. And why we are not getting the GM3? Because it is 0. So which answer is correct? This one. Minus GM1 R01 parallel with R02 parallel with R03 and parallel with what? 1 by GM2. So already 2 or 3 times same type of questions. Okay, Mansavi, this type of questions in exam, HAL, clipper, clamper, DC level shifter. So you have solved all these questions. So already in my session I have given what is that? These are all are the diode circuits are very, very important. And what was the level of the paper? What was the level of paper, guys? Okay, then that is the answer. This is the another question. Easy to moderate. Okay then. And what about the other students? Tell me, what about the paper HAL exam? No, HAL is over. So watch the paper. But the level of the GATE exam and HAL exam is entirely different. Here you have to solve the one. And there was a negative marking. Yes, tell me. There was negative marking in the paper. Okay. This was a very lengthy question in 2016 EC 2 marks. Suppose we are having this type of things, means it is a non-inverting summer. This is the inverting summer, right? You can find the voltage at this point and voltage at this point, then you can equate virtual short concept we can use, and then finally we can find the V0. But remember, an ideal op-amp has the voltage V1, V3, Vn minus 1. These are all odd numbers. Suppose there are n voltages. From V1 to what? Up to Vn. V1 to what? Vn, or n voltages, n voltage sources. All registers are of, here it is 1 kilo ohm, here it is of 10 kilo ohm. Right? There is no negative marking. No? You have taken the risk, means you have to attempt all the questions. No? In my 1 minute short I have given, if there is no negative marking, then you have to attempt all questions, but at the same time you have to maintain the speed, so that we can reach up to last question. N voltages, out of n by 2 is connected here. All odd number voltages are connected here and all even number voltages are connected here, but it is again n by 2. So half voltage is connected here, half voltage is connected here, and one path from this point up to connected ground, and one path from this point it is connected to what? V0. Now, how we can solve? As n approaches infinity, and again infinity, the output voltage is, and the supply, what is the plus V set and minus V set? 15 volt and minus 15 volt. 15 volt and minus 15 volt is the saturation voltage V set. Then how we can solve this question? Now watch this. Guys, because the supply voltage is 15 and minus 15 and n is infinite, no problem, but first get the voltage at this point VA, get the voltage at this point VB, and according to virtual short concept, VA is equal to VB. First equation, VA is equal to VB. And how we can find the VA and VB? Apply the KCL here. VA minus V1 by 1, VA minus V3 by 1, VA minus n minus 1 by V1, and that is a VA minus 0 by 1. So you can write, so VA minus V1 by 1, all are 1, VA minus V2 by 1, plus VA minus Vn minus 1 by 1, plus VA minus 0 by 1. Remember this. How many VAs are here? How many this voltage source are applied? N by 2. Half total voltage n by 2. All odd numbers means n by 2. Then this VA is n by 2 VA. Plus this VA. And is equal to, on opposite side you can write V1 plus V3. This is V3, not V2, this is the V3, and plus Vn minus 1, all odd number. Now, from this you can say what is the VA. VA will become V1 plus V3 plus Vn minus 1 upon n by 2 plus 1. That is the equation. Okay, this is the equation, n by 2 plus 1. This is the VA. Similarly, you can find the VB here. So what is the VB here? Virtual short concept, this is the VB. Again, this is the total n by 2. You can write VB minus V2 by 10, VB minus V4 by 10, Vn. You can write VB minus V2 by 10, VB minus V4 by 10, VB minus Vn by 10, and VB minus V0 by 10. By 10 is equal to 0. 10 is common, 0, And then what is the total number of VB? This. It is N by 2 VB plus VB, last one, and minus V naught. Remember, this is minus V naught also. This is the minus V naught. And at the opposite side, we are having V2 plus V4 plus Vn up to this point. V4 up to Vn. Now, this term is N by 2 plus 1 VB minus V naught, or from this you can write is equal to Vn. Now guys, remember, since VB and VA are equal, if VB and VA are equal means N by 2 plus 1 VB and N by 2 plus V1 VB are also equal. So from this equation, you can write N by 2 plus 1, because the VA is equal to VB, it is nothing but V1 plus V3 plus up to what? Vn minus 1. This is the value. This is the value here, V1 plus V2 plus V3. Now you can write here in this equation, you can replace this by V1 plus V3 plus V5 plus Vn minus 1 minus V naught, and when we are shift, चलो लिख लेते हैं, V2 plus V4 plus Vn. So what is the V naught is equal to? You will get V1 minus V2 plus V3 minus V4 plus V5 minus V6 and so on. Even number, odd number, even number, odd number, minus plus, minus plus, minus plus. Now what is the values of this? What is the values of this? They are cancelled out, or we are just adding the numbers. My dear friends, V1, V2, V3, V4, V5, 6 are respectively 1, minus 1 by 2, 1 by 3, minus 1 by 4, 1 by 5, minus 1 by 6. 1 is negative, 1 is positive. And because of this, finally we will get, because we are getting V naught is equal to V1 minus V2 plus V3 minus V4 plus V5 minus V6 and so on. 1 minus of minus 1 by 2 will become 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6, all become positive. My dear friend, if it is n is infinite, then V naught will become infinite. N infinite means V naught will become infinite, but infinite is not the answer, because of once operational amplifier will will not give the voltage more than what? Biasing voltage. So what is the biasing voltage here? 15 volt. That's why the answer for this question is 15 volt, positive 15 volt plus 1. Operational amplifier will enter into saturation. So that is a very lengthy question, but quickly you can solve in exam, because what is the voltage is given, and then all V1, V2 directly you can say, guys, for example, all V1, V3, V5, just I am giving you the short tricks, all V1, V3, V5 are positive. All odd numbers are connected to non-inverting terminal. Because of this, we will get the positive voltage. All negative values are connected to inverting terminal, because again negative value will become positive. This is positive, this is positive, and n is infinite. Automatically you can say it is a infinite. If it is infinite, it is not possible. You will get the positive value, that is the 15. Directly within 10 seconds I can give the answer for this question. 10 seconds, no need to calculate it. Positive, 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 this is negative, negative, negative. This negative will also become positive, because it is inverting terminal, it is non-inverting terminal. This is positive, and the effect of this is also positive, both positive. That's why answer will be infinite, but not possible, 15 volt. Okay, the next one. Already we have spent 4 or 5 pages, but it is not required. It is a tricky question. This is a very, very important one. Already I have given you the homework. What is the answer for this? Everyone tell me, what about the HEL exam? Okay. Give your feedback. If you have any idea about the questions, then tell me which type of questions, what was your experience. Now, in the operational amplifier shown, the Zener diode Z1 and Z2 clamp the output voltage V0 to plus 5 volt minus 5 volt. Remember, actually here it is a positive feedback. It is visible, it is a positive feedback. Because of the positive feedback, the operational amplifier at this point has two level only, plus Vset and minus Vset. Plus Vset and minus Vset only because of positive feedback. But because of this arrangement, output is limited to what? 5 volt and minus 5 volt. 5 volt and minus 5 volt. Because of this arrangement, output is limited to 5 volt and minus 5 volt. These are called clamping diodes. Now, here again there is a switch. Initially the switch was closed exactly at t equal to 0. The switch is opened. And what is asked, the switch is initially closed and it is opened. Time t1 at which V0 changes its state. This V0 will change its state. So what is the initial value of the V0? If it is 5, then it will change from 5 to minus 5. If it is minus 5, then it will change from minus 5 to plus 5. When? Right? That is the question. At which time you have to find. This is a very, very important one. Now watch this. First, when there is a positive feedback, at this point we are getting the plus 10 and minus 10. But if suppose you are getting the plus 10, this is Zener diode. The breakdown voltage of both the diodes is plus 5. If suppose this is the 470 ohm, you are getting the plus 10 at this point. This is called plus Vset. Then this diode is forward bias, it will act as short circuit, and this diode is in breakdown region, voltage is fixed 5 volt. This is the VZ2, and therefore output is also 5 volt. The output is limited to 5 volt. Second, when this is minus 10, this is minus 10, this is 470, then what is the direction of current? This one. Then this is plus, this is minus, this is forward bias, act as short circuit, ideal Zener diode. And the second diode is breakdown. That is the voltage is what? VZ2, that is the 5 volt. But what will be the output? Minus VZ2. That is minus 5 volt. What is applied here? 10 volt, but we are getting the 5 volt. Remaining 5 volt will come here. We are getting minus 10 volt. Here we are getting the minus 5 volt. What about the remaining? Remaining voltage will come across this resistor. And this is called limiting resistors. And these diodes are called clamping resistors, guys. Clamping resistors. Okay. Now, so this will limit the output at what? 5 volt and minus 5 volt. Okay. Now, what is the nature of capacitor? Capacitor does not allow sudden change of voltage. So initially when the switch was closed, what is the voltage across the capacitor? 0. Because it is short circuited. This is the voltage across the capacitor. Then when the switch was open, again the voltage across the capacitor will remain same, 0. Means just the switch is closed, capacitor act as short circuit. Initially capacitor act as short circuit. When capacitor act as short circuit means what is the voltage at this terminal? For example, this is the VN, negative terminal voltage, or this is the VP, positive terminal voltage. Then this is 10 volt. Because of this short circuit, this is the 10. When the switch is closed exactly at this point, capacitor act as short circuit, this is 10 volt. And guys, remember, if it is 10 volt, this is a very high voltage. Because at this point, maximum voltage possible at this point is plus 1. If it is 5, if it is 5, according to voltage division rule, 1 divided by 4 plus 1, 1 volt. Or if it is minus 5, 1 divided by 5, it is minus 1. So what is the possible value? 1 or minus 1. If it is 10, this is greater than 1 as well as greater than minus 1. Means negative terminal voltage is greater than positive terminal voltage initially. When the negative terminal voltage is high, 100% sure op-amp will be in negative saturation because negative terminal voltage. If it is negative, that's why it is -5. If it is -5, that's why it is -1. 1 divided by 1 plus 4 into -5, that is -1. Voltage at this point is -1. Okay. Then you will get one condition that this is close. Initially it is 10. Initially it is -1. Here it is 10, -10. Here it is -5. Output is -5. Now switch was opened. Situation will remain same. 10. This is -1. This is -1. There is no change in the situation. Everything will remain same. Now what will happen? The capacitor will charge. Once the capacitor will charge, exactly at t equal to infinite, capacitor will act as open circuit because this is DC. So at a t equal to infinite, when capacitor acts as open circuit, there is no current. This is the 10 volt. What is the current through the 10 kilo ohm resistor? 0. This is -10 volt. This is the VN terminal. So what is the VN? -10 volt. VN will become -10 volt. And now guys, you can write the equation for negative terminal voltage also. What was the initial value of the voltage at this terminal? +10. What is the final value? -10. What is the time constant? RC. RC 10 kilo ohm into 100 microfarad. 10 kilo ohm 10 to the power 4 into 10 to the power -4. It is 1 second. Time constant is 1 second. Check my calculation. Now what is, you can directly write the equation for VN. What is the final value of the VN? What is the final value of the VN? What is the initial value of the VN? E raised to power -t by tau. What is the final value of the VN? -10. What is the final? -10. What was the initial? 10. T by 1. Because it is 1 second. 1 second. Then this will become -10 plus 20 ET. Okay, check my calculation. It is a correct one, no? Yes. Then if this is the value VN, this is the equation. Okay. Now exactly at t equal to Tn, Vn will reduce up to what? -1 volt. When Vn decreases and when it reaches to -1 volt or just cross the -1 volt means positive terminal voltage, automatically the output will switch from -5 to what? +5. -5 to +5. What is the value of Vn? When the Vn reach to -1. So let at t equal to T1. At t equal to T1, Vn is equal to -1 and output will switch. Put here -10 plus 20 e raised to power -T1. Then it will become 9 by 20 is equal to e raised to power -T1, or you can say e raised to power T1 is equal to 20 by 9. Take log T1 is equal to log of 20 by 9 because RC was the 1. RC was the 1, so log of 20 by 9. Now you can find the value and then you will get, please check the calculation, and that is the answer for this one, around 0.7 something. Right, please check the answer and you will get the seconds. What is the answer? It is asked in seconds. Yes, it is in seconds. What is the seconds? Log of 20 by 9. Calculate it and give me the comments. This is the answer. Okay. Okay, Mansi, that these are the questions, na? So expected questions or what unexpected questions? We have taken some mock test also and we have shared our experience with you. This is the answer you can find. So remember, you can use this formula anywhere to find the voltage across the Vn, to find the voltage across the Vc, to find the current through V final minus V initial e raised to power -t by tau. Then next one. This is the question. Pin photodiode. Remember, pin photodiode means what? It works in reverse direction. This is the pin photodiode of responsivity 0.8 ampere per watt. What unit will give the formula? Unit, what is the, this is I, what is the photon current upon the power incident? This is called responsivity, right? Is connected to the inverting input of an ideal operational amplifier as shown in the figure. VCC is 15 volt, minus VCC minus 15 volt, load resistor RL is 10 kilo ohm, this one. If 10 microwatt power, this is incident power, this is the incident power, is 10 microwatt power is incident on the photodiode, then the value of the photo current through the load is, through the load, what is the photo current you have to find here? Photo current from this point. Then guys remember, this is the diode, then what will happen? When we are giving the radiation, the current will flow from this direction. Okay. This is according to, this is the ideal operational amplifier. Therefore, 1 minute, this one. This is the direction. Current will flow in the reverse direction from positive to towards ground. This is 0, this is 0, virtual short concept, virtual ground process, this is 0, this is 0. And what is the current enter into the op amp? 0. That same current, this is called photon current, will enter here. This is called feedback current. And then you can find the V0 here. Then what is the value of the current? According to this formula, I. What is the I here? You have to find the I. R. What is the responsivity? R 0.8 is equal to I divided by how much power is incident? 10 microwatt power is incident. 10 microwatt. I multiplied with this, I will become 0.8 into 10 microwatt, and that's why it is a microampere. This much current will flow in reverse direction. Yes, that is a more than sufficient. It is a reverse direction current, very high. 8. Same current will flow through the 1 mega ohm resistor. Same current will flow through the 1 mega ohm resistor, guys. When same current will flow through the 1 mega ohm resistor, this is 0, this is V0. So we can say 0 minus V0 upon 1 mega ohm, 1 mega ohm, that is equal to IF. And IF is nothing but IP, that is 8 microampere. This is the 8 microampere. Now, then therefore V0 will become minus of 1 mega ohm means 10 to the power 6 into 8 into 10 to the power minus 6 means minus 8 volt. Minus 8 volt. Now, what is the current here? This current is required now. The current, this is minus 8. The current will flow in opposite direction from 0 to what? Minus 8. So what is the current here? It will become 0 minus of minus 8 divided by 10 kilo ohm. Divided by 10 kilo ohm. This is the 10 to the power 4. It will become 8 into 10 to the power minus 4. This is ampere, or we can write 800 into 10 to the power minus 6 ampere means 800 microampere. That is the answer. 800 microampere in upward direction from this point to this point. But only the magnitude is asked, then you can, this is the answer for this question, 800. Then what is that? Then the value of the photocurrent, only that is the value. Direction is not given, and the arrow of the current is not given. So remember, this is move in upward direction. Move in upward direction, 800 microampere. This is a very question on special diode, because here we are using the pin diode, guys. Pin diode we are using here. Okay. Now, next question. Consider the constant current source shown in the figure below. Let beta represent the current gain of the transistor. Beta. The load current I0 through the RL. Load current, this is I0. We have to find the I naught. Operational amplifier is connected, Zener diode is connected, reference voltage VCC, R is connected, R2, R1, everything is connected, and answer is given in terms of what? V reference by R, V reference by R, V reference by R, means there is no role of R1 and RL and R2. No role of R1, RL and R2 according to the answer. So how we can solve? What is the current through RL? Remember, if the beta it is given, then this current, what is the current enter into the operational amplifier? 0. This same current, this is called IE. This current is called IB because it is a PNP transistor outside IB, and this current is IC. You have to find the IC, and what is IC is equal to alpha I. And what is alpha? Beta upon 1 plus beta times of IE. This is called IC, and that is nothing but current through the RL. Now you have to find the IE. IE will flow from this because what is the current into an operational amplifier? 0. So what is the voltage at this point? So that we can find the IE. According to the concept of op-amp, virtual short concept, Vp is equal to Vn. This is the voltage is Vn. Now what is the Vp here? So this voltage is VCC. This voltage, Zener diode is in breakdown region. So V reference, voltage at this point Vp will become Vn is equal to Vp is equal to VCC minus Vz, or that is called V reference. V reference is the voltage across the resistor. VCC minus 10. Okay. Then this voltage, these two voltages are same. Now what is the IE? IE will become VCC minus Vn upon R. So VCC minus of VCC minus V reference upon R. This is cancel out. It will become V reference by R. Put the V reference by R here. It will become beta upon 1 plus beta V reference by R. That is the answer. Very, very easy question. So, you can say, suppose we are connecting the RL, but remember, if you are saying that emitter follower means we are giving the input to the base, we are getting the output from emitter. But here we are giving input to the base, we are getting the output from collector. This is the collector terminal. This is the emitter. It is a PNP transistor. It is actually what? PNP transistor. Watch the terminal carefully. So here we are using the Zener diode, BJT, and what? Operational amplifier. Just we are using this technique for stabilization of the circuit. The stabilization of the circuit, or we can say that current through RL is independent of RL. Remember, this current through RL is independent of RL. It depends upon the R. It depends upon the value of R only, right? And that's why voltage across the RL is also independent of what? RL. Also independent of RL. Okay, that is the case. Sorry, voltage depends upon the RL because I naught into RL. Current through the RL. Current through the RL is independent of RL. That is the concept of this circuit. Next one. Here in 2016 now, this is the last paper that was conducted by what? IISC Bangalore. Watch that question. Question we have different types of diagram, right? And what there is some change, but all questions are very tricky. We are having the LED, we are having what pin diodes and different types of diagrams with the LED, with the pin diode and what voltage regulator. But it is a very, very tricky question to watch it, and this is again a very easy question. What is asked here? This is connected. This is a comparator, guys. This is a comparator. There is no feedback. Vi is connected to the positive terminal and you have to find a negative terminal voltage. 10 volt is given, and this comparator, output of the comparator is connected to the BJT. And LED is connected. Always remember, LED works when the current will flow through the LEDs. Or when the current will flow, because when the transistor is in saturation. If it is cut off, there is no current. If there is saturation, the current will flow and LED will glow. Now, following signal Vi of peak voltage 8 volt. What is the peak voltage of this signal? Maximum is 8 volt. Applied to the non-inverting terminal of an ideal op-amp. This is the non-inverting terminal. It is ideal, that's why it is a comparator. Transistor has VBE 0.7 volt, beta 100. LED has 1.5 volt drop, VCC 10 volt and VCC minus 10 volt. This is 10 volt, this is minus 10 volt. The number of times the LED glows. Number of times the LEDs glows. Right. Now, how we can find? Then, number of times LED will glow means what? When this is on, there will be the current, and when there is a current, it will glow. Then, when it will be on? When we are getting the positive voltage here. When we are going to get the positive voltage here plus VCC, when the Vi means positive terminal voltage is greater than negative terminal voltage. And what is the negative terminal voltage here? According to voltage division rule, it will become 2 upon 2 plus 8 into 10. So that is nothing but 2 volt. Means when the Vi is greater than 2 volt, here it is the positive voltage, BJT will goes into the saturation and the current will flow. And the LED will glow. Okay. Then, or it may say, means no need to check whether it is in saturation or active region, but if there is a voltage, positive voltage, then it will allow the current. Once it will allow the current, LED will glow. So Vi should be greater than 2 volt. So where the Vi is greater than 2 volt, this is the first time. This is the first time Vi is greater than 2 volt, and that's why for up to this portion LED will glow. This is the first time LED will glow. Now again second time, again the Vi is greater than 1. For this portion LED will glow. This is the second time. So this is the portion second time. But it is not less than 2, so it will remain glow. At this point it is off. Third time. Third time it will cross the 2 volt. This is the 3. So answer is what? 3. 3 times. Blink कर रहा है ना. ये पूछ रहा है blink कितनी बार किया. On हुआ, off हो गया. On हुआ, off हो गया. On हुआ. 3 बार ये on हुआ है. Okay, LED. इसका आंसर है 3. Okay then. Next one. One minute. This question is given. This answer is also given here, but how to solve this question, that is more important, right? Okay, these all are the questions: power, energy, signal, and avalanche versus Zener diode, emitter, follower. Okay, then an operational amplifier has a finite open loop voltage gain of 100 volt. Its input offset voltage is 5 millivolt and is modeled as shown in the circuit. The amplifier is ideal in all other respect if V input is 25 millivolt. If V input is 25 millivolt, this is 25 millivolt. Guys, remember in this type of questions, if the bias voltage is given, what is the total voltage at this point? 5 plus 20 means 25 millivolt. This is already 25. Input is 25. Then 5 plus 25, it will become 30 volt here. 30 millivolt here. And this is a non-inverting operational amplifier, but practical non-inverting operational amplifier. The gain is not infinite. The gain is 100. If the gain is 100, then what will be the output? Then, if it is a practical operational amplifier, then you can write what is the gain for the practical AV open loop gain upon 1 plus beta AV. That is the gain. And what is the beta here? R1 upon R1 plus RF. What is the R1? This is the 1 kilo ohm is the R1 upon R1 plus RF. This is the 15 kilo ohm is the RF. What is the value of the beta? 1 by 16. Then what will be the gain? Will become 100 upon 1 plus 1 by 16 into 100. that will become 1600 times of 116. 16 times of 116. That is the gain actually, practical gain. Now what is the input at this point? This is 30, this is 25, this is 5, that is the 30 millivolt. That's why the output will become 1600 divided by 116 into 30 millivolt, 30 into 10 raised to power minus 3, and you will get the output. If the answer is given in millivolt, you can find the answer in millivolt. Otherwise, you can give the answer in what volt. That is the formula. Very easy. 413.79 millivolt. Calculation is your part. 413.79 millivolt. Next. Next question. For the circuit shown in the figure, R1, R2, R3, all are 1 ohm, 1 ohm, 1 ohm, 1 ohm. What is the value of the C? 1 microfarad. What is the L? 1 microhenry. 1 microfarad. If the input is cos of 10 to the power 60, where is the input? This is the. So what is the omega? 10 to the power 6 radian per second. So what will happen? The student will first of all convert this into j omega L. They will find what? Minus j by omega c. And they will waste their time. Waste their time. What is asked in the question? Then the overall voltage gain. You have to find the overall voltage gain. At the last, you can apply the 1 by SC. But if you want to find the gain, very, very simple. First of all, what is the impedance? SL. Gain. SL. This is R1. So what is the voltage at this point? That is the V01. Then what is the relation between V01 and Vout? This is the RF. This is the R1 or Z1. Right. Now this is a non-inverting operational amplifier. The overall gain is nothing but V out upon V01. V out upon V01, the gain of the second into what? Gain of the first. V in. Now, gain of the first is, it is a non-inverting op amp. That's why V01 upon V in will become 1 plus RF. RF means R1 upon R. RF upon R1 at SL. This is the gain for the first one. Now, what is the value of L? 10 to the power 6. You can write L is equal to C because the value of the L, because the value of the C, both are equal. You can also write it like that. No need to put the value 1 by SC because the value of C and value of L are equal. So you can write like that. Okay, this is the first. What is the second? V out by V01. V out by V01. This is the non-inverting, inverting operational amplifier. What is the inverting? RF upon Z1. So R3 upon Z1. What is the Z1? R2 plus 1 by SC. R2 plus 1 by SC. The impedance is because of that 1 by SC. What is the R3 and R2? 1, 1. 1 upon 1 plus 1 by SC. And what is this? R1 is also 1. So R1 is 1. You can put the R1 1. R1 1. L is equal to C. Now when we are multiplying these two, but remember this is inverting, that's why it is negative. This is negative. To multiply these two, so what is the V0 by Vin? This term is cancelled out by this term because it is in numerator, that is in denominator, and you will get the answer minus 1. You will get the answer minus 1. That is the question. Very, very simple one. Minus 1 is the answer. No need to use what? Omega. No need to use the omega here. That is redundant. 10 to the power 60. Gain is fixed, independent of omega. Now, next question. In 2002, EC 2 marks from oscillators. The circuit in the figure employs positive feedback and intended to generate the sinusoidal oscillator. Sinusoidal oscillation means Bar-Hussein criteria you have to satisfy. If at a frequency f0, the feedback factor Vf by V0, feedback factor means Vf by V0 is equal to 1 by 6 angle 0. Then to sustained oscillation at this frequency, sustained oscillation what at this frequency, what is the relation between R1 and R2? What is the Bar-Hussein criteria? Mod of A beta should be equal to 1. Mod of A beta should be equal to 1. So this is a non-inverting operational amplifier. So non-inverting operational amplifier and mod of A is equal to what? 1 by beta. What is A? 1 plus Rf by R1, R2 by R1. And what is the 1 by beta? It will become 6 because beta is given as 1 by 6. 1 by beta will become 6. So 6 minus 1, 5 and R2 is equal to what? 5 times of R1. That is the answer. 5 times of R1. This is the answer. A. Next question. So remember guys, this is a golden opportunity for you. Tomorrow you can give what? Scholarship test. And window will be open for what? 12 hours. 9 a.m. to what? 9 p.m. 10th of September. You can avail get up to 90% off on our program. And you can start your journey with us. Okay. So try to give this test and register yourself now, right? And you can also check what about your gate preparation. This is useful for what? Analysis of your gate preparation. Now, that is the workshop by Asu Jangra sir, MT from IISC Bangalore. Ideal strategy to excel in GATE 2024. Live interactive workshop on 13th of September means coming Tuesday at 7:30 p.m. Okay, so this is for you guys. Attend this and you can ask your doubts also. If you have any queries, any questions, then you can ask. Next question is, then now quickly we will solve 5 or 6 questions from electrical branch. This is 45. The forward resistance of the diode shown in the figure is 5 ohm and the remaining parameters are same as those of ideal diode. The DC components of the source current is, what is the DC component? This is a half wave rectifier guys. If this is a half wave rectifier, then okay, so Acha, you have given that addressing modes questions, Avalanche versus Zener. So these all are the questions to Mansvi, that is you are giving the good feedback. HAL exam, this type of questions guys, that is important information for you. And all other students, tell me what about your paper, kaisa gaya bhai HAL? So for half wave rectifier, this is 45. The internal resistance of the diode is RF. V gamma is 0 because otherwise it is ideal. So RF is 5. This is 45 and this is sinusoidal signal here. So what is the peak value of the current IM? IM is given by Vm upon Rf plus R. And then it will become Vm upon 50. So what is the IDC value? Im by pi for half wave rectifier. And that's why answer is what? Vm upon 50 pi. This is the answer. Very easy. Because otherwise the diode is ideal. So answer is Vm by 50. In GATE 2002, it is a 1 mark question only. Then this is a bridge rectifier guys. 4 diodes are connected, we are getting the input, here we are getting the output. So this is a bridge rectifier. But what is asked here? What is asked here? 1 minute. Give me 1 minute. What is the answer for this one? In a single phase diode bridge rectifier shown in the figure, the power across load resistor is 50 ohm. R is equal to 50 ohm. What is the power? Source voltage is 200 sin omega t, where omega is 100 pi radian per second. Now, if the power is asked, this type of questions, right? What is this? Your answer is correct, Mansavi. Power means what? Normally we have to find the average power, because if the DC power is required, they will definitely use the word find the DC power. But here if the power, so by default we have to find the average power or effective power. So what is the average or effective power? It is V RMS square. What is the power? V RMS square upon R. And what is the RMS value for the bridge rectifier? It is a full wave rectifier. V RMS is nothing but Vm by root 2. And what is the peak value of the input? Because without transformer we have connected to 200. So it will become 200 divided by root 2. So that power will become square of that. 200 divided by root 2 square of this upon 50. And you will get 400 watt. You will get 400 watt. So this is the answer. Average power. So in a gate, it is in 2002, in 2000, around 15 or 16 or 20, same type of question, find the power. Again, we have to find what average. The word used here, average power. But remember, don't confuse with the average power, effective power, or useful power. These are the words we are using in what? Steady state analysis of sinusoidal signal. Right? If it is asked, find the DC power, then find the DC, VDC into IDC. Otherwise, find the this power, average or effective power, guys. Okay. Then next one. This is again in 2008 electrical diode circuit question. The equivalent circuits of a diode during the forward bias and reverse bias conditions are shown in the figure. If such a diode is used in clipper circuit of figure given above, the output voltage of the circuit will be. What is the output voltage? Then it is a practical diode. How we can say? Because according to the model, this is the V gamma cut-in voltage and this is the RF. When it is forward bias, it is not replaced by the short circuit. V gamma and RF, it is given means practical diode. Now, if the breakdown, this is the voltage, watch this diagram. 1 minute, what is the diagram here? Watch it carefully. This is the diagram. This is the 5 volt battery is connected here. Because of this 5 volt, this diode is reverse bias. And this is called positive terminal voltage. But it is a practical diode. If it is practical diode, always remember that the minimum drop is required. V gamma is 0.7 volt. And this is Vn. This is Vn is 5 volt. Then what should be the Vp? Vp should be greater than or equal to Vn plus drop across the diode. Means 5.7 volt. Just I am assuming that the drop is what? 0.7 volt because it is a practical diode. So when the voltage at this point is greater than 5.7 volt, then this diode will conduct, otherwise the diode will not conduct. What we are doing, initially we are taking let the diode is off. When the diode is off, then what is the output voltage? This is Vi, this is 10 kilo ohm, this is 10 kilo ohm. Therefore, the output will become Vi by 2. According to voltage division rule, output will become Vi by 2. What is the input? 10 sin omega t. That's why the output will become 5 sin omega t. So what is the highest value of the output? 5 volt. And what is required here? Greater than 5 volt, 5.7 or greater than 5 volt. If the greater than 5 volt is required, but we are getting only 5 volt, that's why the diode will never conduct. And answer is 5 sin omega t. So which answer is correct? 5 sin omega t. If you are watching the answer, this is the 5 sin omega t. There is no clipping, only the output is what? Vi by 2. Output is Vi by 2. Answer A. So diode will not conduct here. That is the case. Then quickly we will solve 2 more questions. Then guys, it is a voltage doubler circuit. This is called negative clamper and this is called negative peak detector, and this is the load is connected here. In the voltage doubler circuit shown in the figure, the switch S is closed at t equal to 0. Assume the diode D1 and D2 to be ideal. Load resistance to be infinite. Yes, normally we are taking this is infinite so that the capacitor will not discharge. Initial capacitor voltages to be 0. The steady state voltage across the capacitor C1 and C2 will be. So it is a standard question of voltage doubler. Then what is the answer here? It is given VC1 10 volt, VC2 5 volt, 10 volt, minus 5 volt, 5 volt, 10 volt, 5 volt and minus 10 volt. Remember, when the switch is closed here, now current will flow like this. Then this capacitor, first of all, this capacitor will charge by this VM. And what is the VM here? 5 volt. This capacitor will charge like VM, that is the 5 volt. Now, this is a negative clamper. That's why output will clamped here. This is 0. This is minus 5 and this is minus 10. Right? This will become minus 10. This is a negative clamper. It is negatively clamped here. What is this? Negative peak detector. And the current will flow like this. When the current will flow in opposite direction, so what is the maximum value? Minus 10. And this capacitor will charge in negative direction up to what? 2 Vm. So what is the VC2? According to the polarity plus minus, and that's why VC2 will become what? Minus 10. Under steady state, the voltage across this capacitor is 5 volt and voltage across this capacitor is what? Minus 10 volt. It is a voltage doubler, guys. It is a clamper. It is a negative peak detector. Voltage doubler, and that's why the answer is D. 5 and minus 10 volt. It is visible. VC1 is 5 volt. VC2 is what? Minus 10 volt. This is the answer. 5 volt and minus 10 volt. Easy question, theoretical question, doubler. Now, just I want to give some homework, guys, and just I am giving you the hint. If you find any difficulty, then please inform me. This is the question. The cut-in voltage of the both Zener diode DZ and PN diode D is shown in the figure, 0.7 volt when it is forward bias, while the breakdown voltage of the Zener is 3.3 and the reverse breakdown voltage of the diode, this is diode, it also has the breakdown voltage. Both have the breakdown voltage. The breakdown voltage for this diode is 5 volt. Breakdown voltage for this diode is 3.3 volt. When the diodes are forward biased, the drop is what? 0.7 volt. Then what is asked? The other parameters can be assumed to be same as those of an ideal diode. The values of the peak output voltage V0 are. The values of the peak output voltage V0 are. Then how we can find this? First of all, when we are taking the positive half, maximum value 10 volt. This diode is breakdown. So what is the drop here? 3.3. This diode is forward bias. What is the drop? 0.7. So 3.3 plus 0.7. What is the drop here? 4 volt. If suppose this path will not conduct, then what will be the voltage? 5 volt. If this is maximum 1, 1. What is the maximum voltage? 5 volt. But it will not reach to up to 5 volt because when it reaches to 4 volt, this diode will break down and this diode will conduct and output is fixed at 4 volt. And that's why the maximum positive voltage is 4 volt. Maximum positive voltage is 4 volt. Now, same thing, watch in what? Reverse direction. When it is in reverse bias, it is minus 10. This is minus 10. The current will flow in this direction. Then you can say, sir, it is reverse bias, it is 5 volt, it is forward bias, 0.7 volt, and that's why the output is minus 5.7 volt. Okay, but check. In this path, total 5.7 volt is required. Suppose this path is not conducting. Then, if this path is not conducting, this is the minus 10, means this is minus plus 10. This is 1 ohm, this is 1 ohm. So what is the voltage from this point to this point? Only 5 volt. And output is minus 5 volt. In a reverse direction, what is the maximum voltage? Magnitude is 5 volt. And what is the required so that this path will conduct 5.7? Not possible. Means when the input is negative, this path will not conduct. And that's why the maximum output voltage when the input is negative is 5 volt. Which answer is correct? 4 volt in positive half cycle and 5 volt in the negative half cycle. These are the peak, the values of the peak output voltage. 4 volt in positive half, 5 volt in negative half cycle. That is the answer. Okay, then this is the question. Next one. So you can join our app, guys, everyone, and remember, on our app you can go through the mock test also. Okay, so Mansuri, you have given the B option. Now this is the question. Transistor circuit is given below. The Zener diode breakdown voltage is 5.3 volt. This is the Zener diode breakdown voltage 5.3. As shown below, take base to emitter voltage drop to be 0.6. Base to emitter, where this is base, this is emitter, 0.6. The value of the current gain beta, you have to find the current gain beta this time. How we can find the beta here? It is a 1 mark question only. If this is points, for example, this Zener diode is in breakdown because it will allow the current. So what is the voltage at this point? 5.3. This is called base voltage. So what is the voltage at this point? V. This voltage is 0.6. So you can say VBE is equal to what? VB minus VE. What is the VE is equal to? VB minus VBE. Directly you can subtract 5.3 minus 0.6. That is called 4.7 volt. 4.7 volt divided by, this is nothing but 0.47 milliampere. This is in ohm, this is in kilo ohm. What is the IE? You can find IE is equal to V upon RE. 4.7 upon 0.47 kilo ohm, that will become 10 milliampere. Value of I is 10 milliampere. Now, to find the beta, you have to find I1, you have to find I2. It is given what is the base current. Why? Because IE is nothing but 1 plus beta times of IB. So what is the 1 plus beta? 1 plus beta is equal to IE upon IB. And then from here you can find the value of beta. That is a simple logic. So I1, what is the I1? 10 minus 5.3 upon 4.7. 10 minus 5.3 upon 4.7, that is 4.7 upon 4.7, 1 milliampere. This is the value of I1. And what is the value? 0.5 milliampere. I2. So what is IB? Very easy. IB is equal to I1 minus I2. 1 minus 0.5, that is 0.5. What is the IE? 10 divided by 0.5, that is the 20. 1 plus beta is 20. So what is the beta? 19. 20 minus 1, that is what? 19 is the value of beta. 19 is the value of beta. This is a very, very easy question. Find the IB, find the I, get the relation, and then you can find value of beta. This is the numerical answer type question, 19. Now, guys, we are having the different types of questions. One question is from current mirror circuit, right? One question is from current mirror circuit, guys. Two perfectly matched silicon transistor are connected as shown in the figure. Perfectly matched silicon transistor Q1 and Q2. Assuming the beta of the transistor to be very high, the forward voltage drop in the diode to be 0.7 volt. Forward voltage drop from this point to this point, it is 0.7 volt. It is a question on current mirror circuit. The value of current I is, if both are identical, then I will be equal to what? I reference. Why? Because beta is very, very large. It is given beta is very high. That's why the base current is negligible. and this current and these currents are equal, then you have to find only the I reference. This is the question on current mirror circuit. Then how we can find the I? You have to write the KVL from this point to this point only. And what is the voltage here? 0.7. And what is the voltage at this point? -5. So when I am writing the KVL, so what is the I reference? 0 is equal to 1 into I reference plus what is the drop across the diode? It is given in the question, 0.7 volt. What is the VB? 0.7 volt minus 5. What is the I reference? I reference is nothing but I. 5 minus 1.4 upon 1, that is 3.6 milliampere. Because resistor is in kilo ohm, answer will be in milliampere. So now these days we are getting the question from current mirror circuit, but it is based on what? MOSFET, right? So it is based on what? Transistor. Normally we are getting now MOSFET, current mirror circuit. Now it is time for homework, guys. Everyone give me the answer for these two questions. First of all, very easy. This is a P block where the gain, remember, this is the V in, this is the V out. V in is positive but V out is negative. The slope is negative, -1. So what is the V out here? Minus of V in. Okay. Then here V in is negative. Watch this carefully. V in is negative but V out is positive. It is in second quadrant. V in is negative but V out is positive, but we are getting the minus V in again. Both. It is the case then. But it is in, when the V in is negative, then it will give the positive value. It is when it is positive, it will give the negative value. Now the block diagram of two half wave rectifier are shown in the figure with the transfer characteristics of the rectifier. It is desired to make the full wave rectifier using about two half wave rectifier. The resultant circuit will be. So this is the half wave rectifier, right? And yes, full wave rectifier. So this is the P, this is the Q. Now here for positive value we are getting the negative, this type of curve. If this is the sinusoidal, from the first for positive we are getting the negative. This is the output of P, and what is the, we are giving this one. For negative we are getting the positive. And for positive portion we are getting the 0. So this is the case. Then V, P and Q, the resultant circuit will be. Now watch this diagram carefully, which will give you the full wave rectifier. Full wave rectifier here. Then guys, what about the Q? Q is what giving, it is Q is converting the negative portion into what? Positive portion. Right? To watch this, there are 4 diagrams. First one, second one, third. In first, both are connected to inverting op-amp. Second, one is connected to non-inverting terminal, one is connected to inverting terminal. Okay, so watch it carefully. What is the relation here? Right, already I have given at this point V out is equal to minus V in, V out is equal to minus V in. Then you can compare it and draw. Then that is the third answer. Q and P, we have changed the block and both are connected to what? Non-inverting. This is a very conceptual question. So this is the homework. And please give me the answer on my Telegram channel. If you want to send a descriptive answer, yes, I will check. Okay. And try to solve this question. Very easy one. Already I have given you the hint. So in this way, we can make a full wave rectifier. Full wave rectifier. Second question. For the circuit shown below, taking the op-amp as ideal, the output voltage V out in terms of the input voltage V1, V2, V3. Yes, V1, V2, V3 means what? You can find, I'm giving you the hint, that what is the voltage at this point? This is called Vp. Okay, and then first of all find the Vp, and this is called Vn. So there are two options. Find the Vp means what? What is the current enter into the op-amp? 0. So Vp will become Vp minus V1 by 4, Vp minus V2 by 1, and you can find the Vp in terms of V1, V2. And then what is the Vn? Vn minus V3 upon 1, Vn minus V out upon 9. You can write the KVL here, and then you can equate and Vp and Vn, and you can find the answer here. you can find the answer here. Okay, that is one way to solve this question. Second way, you can apply what? Superposition theorem. Second way, you can apply the superposition theorem, and in that case you can very fast get the answer for this one. First, apply the superposition theorem, make the V3 0, this will become non-inverting op-amp, make the V2 0. Then what is the drop here according to voltage division rule? I am just giving you the hint quickly. First question was only, right? And then you can find the remaining answer. This is 1, this is 9, this is 1, this is ground. No need to redraw the diagram, just I am giving you the hint here. This is 1, this is V1, this is 4. Now make the V2 0, V3 0. Now what is the drop here? Vp. 1 upon 1 plus 4, 5. So what will the V0? 1 will become 1 plus Rf by R1. 1 plus, this is Rf, this is R1 into Vp. And that will become 10 into Vp. What is the Vp? 1 upon 1 plus 4 into what? V1. That is become 2 times of V1. 2 times of V1. Similarly, you can make the V1 0, V3 0, and then you will get the another output, right? That is the 8 times of V2. Then guys, third time when we are making both 0, V1 and V2 0, it is just like an inverting op-amp, and you will get the 9 times of V3, minus 9 times of V3. With the help of superposition theorem, you can solve and give me the answer. Already I have given you the hint, answers. So you will get this B option, but you have to give the solution, complete solution for this question. By using the superposition theorem, directly you can watch. You can apply superposition because it is a linear integrated circuit. Then next question. Next one. Now, okay, now you have to give the solution, send me the solution on my Telegram channel, that is Electronics by Sanjay Rathi. So this is the another one. This is the question based on what? Symmetric trigger circuit, because this is 10 kilo ohm, 3 kilo ohm, 2 volt, VR it is connected. Then this is the 10 sin omega t, 100 kilo ohm, it is given. It is a symmetric trigger circuit. Then what is the output voltage V0 of the symmetric trigger circuit is plus 15 and minus 15. Assume that the op-amp is ideal. Then when the instantaneous value of the input sine wave is, when the instantaneous value of the input sine wave is, when the output will change from plus 15 to what? Minus 15. तो आपको क्या करना है? You have to find the upper threshold level and lower threshold level, right? Or when it will change from 15 to minus 15. So initially it was 15 volt. When it was 15 volt, so what is this? You have to find the upper threshold level. Or when the input cross the upper threshold level, then the output will change from plus 15 to what? Minus 15. Plus 15 to minus 15. Find the value. 2 volt is given. What is the value of the upper threshold? And then you can find the value. This is the hint for this question. Try to solve this one. That is the question on what? Symmetric trigger circuit. Then next question is on a general filter circuit is shown in the figure. Here we are connecting the VI. R3, R4, R1, R2, C is connected here. This is a general filter circuit. What is the name of this filter? What is the answer? It is a linked question. So what is the question here? What is this? If R1, R2 is equal to RA and R3, R4 is equal to RB, the circuit acts as all pass filter, band pass filter, high pass filter, low pass filter. So what we have to do? We have to find the gain only. When we are finding the gain here, how we can find the gain? Again, you can apply the superposition theorem, or you can equate the inverting terminal voltage and non-inverting terminal voltage. VA is equal to VB and find the V0. And you can replace it by 1 by SC. This is R4, R3, R1, R2. It is given RA or RB. First of all, find the V0 by Vi and arrange it. When you are going to arrange it V0 by Vi and finally check exactly at omega equal to 0, you will find that gain is 0. Overall gain is 0. And omega equal to infinite, you will get the finite gain or maximum gain. Means it is a high pass filter. Means it is a high pass filter, guys. Right? So check this. So Mansi, no, you are just checking this C only. But it is also connected R3 and R4. So first of all, find the VA, then find the VB, or you can directly apply the superposition theorem. What is the output because of that? What is the output because of this? And then arrange the situation and finally put the value of omega is equal to 0 and omega is equal to infinite. Omega increases, gain increases, then we can prove that it is a high pass filter. Now what is the linked question? The same question, the output of the filter given to the circuit shown in the figure, the output of that filter remaining, previous one, high pass filter, is given to this filter. This is a low pass filter, R4 by 2. So remember, high pass filter followed by the low pass filter. What is the high pass filter followed by the low pass filter? High pass filter followed by the low pass filter is band pass filter. High pass filter followed by the low pass filter, it is nothing but band pass filter, but condition applied. The cutoff frequency of high pass filter should be less than the cutoff frequency of low pass filter. Then it acts as what? Band pass filter. And that is the characteristics of band pass filter, this one. This is nothing but a low pass filter. Very tricky question. And because that is in syllabus of gate network, circuit theory as well as analog. That is the question related to analog and network. High pass filter and band pass filter, guys. Okay, and this is what last question. This is a very easy. It is a low pass filter actually. It is a standard circuit of low pass filter. When C is connected here, R2 is connected here, R1 is connected here, low pass filter. So no need to solve it. But the previous question you have to prove. Directly you can't say that it is a low pass filter. I think now it is clear. So this was the last question from electrical branch. It is a 1 mark question. So I have given 3 questions as a homework. Everyone try to solve this. And already we have started the crash course for GATE 2024. Guys, we have discussed the question. Now, if you want to solve questions, you want to attend the free classes, 3 days free classes, then install the BYJU'S exam prep now. And you can avail 3 days free classes here. This is the GATE 2024 crash course. For electrical branch as well as for electronics branch, you will get live classes, recorded lecture, study material, practice question, mock test, everything available there. Okay. So, and you can also call at this number. First of all, install the BYJU'S exam prep app now. Then, this is my Telegram channel, Electronics by Sanjay Rathi. I will upload the PDF of this session quickly on what? My Telegram channel just after this session. So join my Telegram channel if you want to download this PDF. Okay, and then give me the answer for the assignment questions. Okay, then thank you for attending the session. You are on BYJU'S exam prep. Thank you and good luck for all coming exams.